Hi everyone, just wanted to take a moment to talk a little bit about how to solve a quadratic equation by factoring. So, in general, it's not always convenient, right, to graph or use a table. In particular, I mean, if you're using a table, you're either plotting, you're either plugging in a bunch of points and then making a table, at which point you might as well just graph, or you're using just like a piece of technology like Desmos or a graphing calculator or something like that. But what if you don't have one of those, or you kind of just need to quickly find it and don't want to go through that process? Well, what you can do, and probably the most common way of solving quadratic equations, is going to be by factoring. All right. So as you know from before, when we were going over factoring, right? If you had x squared plus bx plus c, you would look for factors of c that added up to b. Then when you had the a in the front, right, you had ax squared plus bx plus c. Look for factors of a times c that added up to b, and then you had to go through the process of factoring, factoring out like terms and things like that. So once you went through all that, you got something that look like this: x minus 9, 5x plus 2. And then when we looked at factored form, right, we were looking for something like, x minus 9, right? I told you that it was going to intersect at 9, right? It was going to be the opposite. So, well, why is that true? Well, why is that the case? Well, it really comes down to this thing called the zero product property, which basically is saying if I multiply two things together and it equals 0, well, one of them is 0 or they're both 0, right? So essentially what we're saying is either, since this equals 0, either this is 0 or this is 0, or I guess both is 0. In which case it would be a lot less interesting, I suppose. Granted, since both have x, they can't both be 0 at the same time. So how are we going to solve this then? Well, since we know either this is 0 or this is 0, we'll just set them both equal to 0 and see when they would be 0. So x minus 9 equals 0, or 5x plus 2 equals 0, right? So I'm just going to solve for x equals 9. So as you can see here, I got the opposite, right? Because I added it over to this side. So this is why before, when we were talking about factored form, we were saying that the x-intercepts were going to be the opposite, right? So it comes down to this, right? So now I have an option of 9, right? Because if I plugged in 9, this would be 0, so the whole thing would be 0, because 0 times this would be 0, right? Now over here, I'm going to subtract the 2, I'd get 5x equals negative 2. So x is going to be negative 2 fifths, which makes sense, right? If I multiply this by negative 2 fifths, that'd give me negative 2. So negative 2 plus 2 is 0. So the whole thing would be 0, right? So now I have my two solutions: negative 2 fifths or 9, right? And that's it. And if we were to graph this, right, these would be the x values of the x-intercepts, right? These would be the x-intercepts. So we already know if we were to graph this, I'd have the point 9, 0 and negative 2 fifths, 0 on my graph. Now, obviously, normally what we were doing once we got that was we were averaging them, we would find the vertex. Now, obviously, that's not a very pleasant thing to do, but, it kind of would still hold from there, all right? So if we looked at this, right, you want to double check, even though you'd have the 47 when you plugged in the 9 here, it's times 0, so it's still 0. So again, the nice thing about this is there's kind of a fail-safe method in that if you have time, just plug it back in and see if it works. If it works, then you did it right. If it doesn't work, well, something went wrong. Most likely, you forgot a negative. All right, so for something like this, right, this is relatively straightforward. All you're doing is you're just setting them equal to 0. So I'll do this first one, and you can do I'll do them both. So 2x minus 1 equals 0. X plus 3 equals 0. So x equals negative 3. X will equal, add the 1 over here. 1 divided by 2 is 1 half. 1 half, negative 3. There's a couple ways you can write your solution. Sometimes it's just looking like sometimes this is fine. You could write it at like this. Negative 3, 1 half, right? The set these are the set of numbers that would make it equal to 0. Those are pretty much the only, those are the two that you tend to see. Okay, so same thing with this one. Simple enough, right? You use the zero product property. So one of these has to be 0. So let's set them both equal to 0. -3, x equals -3 halves. 3x equals 1, x equals 1/3. All right, and there's our 2. Okay, so you might be asking yourself, when are we going to end up with a situation where you're not going to get 2 solutions? So that's a good question. All right, so that's a really good question. So when are you going to end up in a situation where you don't end up with 2 solutions? Well, that's going to be where you factor something and you end up with like this, x minus 1, x minus 1, right? That's going to be where there's one solution, right? That makes sense. And when there's no solution, it's just not going to be factorable. All right, so how can you use factoring to actually solve this? Well, so the first thing that you always need to make sure to do before you start factoring is write it in standard form. Okay, so if you have x squared plus 9x equals -20, bring that 20 on over, right? You want to get it equal to 0. Okay, so you would have x squared plus 9x plus 20 equals 0. Now from here, I'm going to go through the factoring process, right? I need factors of a times c. A is just 1. So I just really need factors of 20 that add up to 9. Well, that's easy, 4 and 5. Now, a is just 1, so I already know it's going to be 4 plus 4 plus 5. Now, from here, we already know what to do, right? We just said each of these equal to 0, so my answer is going to be -4, -5. Okay. Simple enough. The hardest part about this is usually just the factoring. Right, so again, you want factors that add up to 9. Don't forget that. It's very easy to kind of forget about factoring if you haven't used it in a while. But ultimately, you're just finding factors that add up to the middle term. All right. So let's go through this process. All right, well, here's what I have. It's already in standard form, so let's get started. I need factors of 64 that add up to 16. Well, guess what? 8 and 8. So I have x plus 8, x plus 8 equals 0. Now, when you end up with something like this is essentially the same thing, right? We know from before this was x plus 8 squared, same thing. Which pretty much means that we already know this is the vertex, right? Because then the vertex is -8. So essentially what I would do is if I set them both equal to 0, you're just going to end up with the same thing twice equal to 0. So it's really just the 1, right? Because if I did the other one as well, it's still just this. Okay, so this is a situation where you only have one solution. All right, now let's do this one over here. So first things first, get it in standard form. So I'm going to subtract it from both sides. Okay, now I need to find factors of -64 that add up to -12. Okay, so let's see, what do we have here? So since they're both negative, well, one of them has to be positive, one of them has to be negative, the bigger number has to be negative. Okay, so I want factors of -64. What do we have? Let's think. So, well, we had 4, 8, and 8, which is not going to work. So what else do we have? Well, if you kind of essentially break it apart, what's 8? It's 4 times 2. So we could also have 16 times 4, which should work. So -16 times 4, right? Because -16 times 2, -32 times 4 would be -64. All right, so we have x minus 16, x plus 4, right? You would eventually be able to find those out. So you know your answer is going to be 16 and -4. Alrighty, pretty straightforward. I think it's just the hardest part is going to, once again, be factoring. Okay, so almost done. Really quickly, do just want to talk a little bit about word problems. And we're kind of using the word problems here as a means to kind of think about it kind of visually, right? Realistically speaking, what's happening with factored form, right? It's good for area. It's length times width. So you're very commonly, when you're dealing with factored form, going to have an area word problem. All right, so a museum vault has an outer steel wall with a uniform width of x. Okay, so there's the width of x. The area of the museum vault ceiling in the outer steel wall is 1,664 feet. What is the width of the outer steel wall? So here we do know that this is 20, and this is, this is 40. We know over here is x, right? So if that's x, this is x, right? If this is x, we know this is also x because it tells us it's uniform, right? So it's x and x. So that would essentially mean I would have 2x plus 40 times 2x plus 20, right? And we know if we multiply these together, it has to equal this number. All right. So from here, what do we do? Well, we have to get to the point where we can factor. So we have to multiply this out, unfortunately, to be able to factor. So that's going to be 4x squared. That's 40x plus 80x plus 800. So this would be 4x squared. Oops, I forgot the 1664. Plus 120x. Now I have to bring this over. So what is going to be 800 minus 1664? So that's negative 864 equals 0. Now, you might be tempted to just say, well, all right, I can deal with the 4, right? I mean, I can do this, right? 4 times this, but I don't want to, right? If we can get rid of something to make it easier, do it. All right. What do they all have in common? They're all divisible by 4, right? 864 divisible by 4, well, that's 216. 120 divisible by 4, that's 30. 4 divided by 4 is 1. So, right, that'd be x squared plus 30x minus 216 equals 0. Now, from here, right, we have to find factors of 216. Well, what is 216? So, what do they have in common? Well, let's see. We know 216 is divisible by, it's divisible by 4 again, but this gives us 54. 216 divisible by 16 does not work. 216 divided by 12, well, that can be, yep, okay, so we have 12 and 18. All right. So we would have 12 and 18 there. The other thing we have to be careful of is one of these has to be negative, one of these has to be positive. Right? All right, so sorry, hit the wrong button. So one of these has to be negative, one of these has to be positive. So obviously 18 and 12 does not work. It's tempting, right? It's tempting, but one's positive, one's negative, so you can't just add them together. So that won't work. So what else can we find for factors of 216? Well, it is divisible by 36, and it's also divisible, would give 6, right? So 216, negative 216, we have negative 36, positive 36, I'm sorry, and negative 6, and that will add up to positive 30. So I'd end up with x plus 36, x minus 6 equals 0. I solve, I would get x equals negative 36. Now this is one where you kind of have to, might have to play around with numbers to get it right. I had to think about that one for a second too. Now, what's the question asking us? It's asking for the width. Does it make sense for me to have a width of negative 36? No. So my width is 6. All right. So do be careful. Make sure you pay attention to what the number is, the problem's actually asking you. Right? You substitute it in, make sure it would work. All right. So similarly, you could do this process with another thing here. You just have to be careful. And make sure you get it all set up. All right, Alrighty, but ultimately you're going to go through a very similar process. So that is how you're going to solve quadratic equations using factoring. Predominantly, the hardest part is going to be really the factoring. Once you factor it, it's not too bad. You just set it equal to 0. All right. Well, let me know if you have any questions, and have a great day.